Hey there, welcome back. Friends, today we will discuss static synchronization. In order to understand this concept, we will take up the same program which we have developed when we were discussing about synchronized method concept. So here is the program where we have this synchronized method and everything works perfectly, right? So every time when we execute the program, even though this particular method is being called by multiple threads, we are getting a consistent and a proper result, and the reason is definitely a synchronized method. Now friends, in here this particular class is not a static class. This method is not a static method. Take a note of it, and whenever the elements are not static, definitely it is derived by objects. Now friends, moving forward, when we are calling this generate method, we are taking help of an object and the lock is based on this object. Understand this. Whenever we make use of synchronized keyword, definitely Java applies some locking mechanism in between. So when we are executing this program, the lock, the intrinsic lock, the monitor lock is based on this object bracket. As a result, we are getting a consistent result, which is cool. And before, I have already shown you one issue. If, for example, we have two objects, for example, bracket 1 and bracket 2 maybe, and we are calling in the generate method based on bracket 1 and bracket 2. Now, Java will apply two locks, two intrinsic locks, and because of these two locks, the multi-threading will work and the generate method will get executed simultaneously. As a result, there could be some issues. Let me show you. So in here, we may get inconsistent result when we are trying to execute it multiple times. Here we go. So there are a couple of times where we are getting some unwanted, unexpected result. Why there is unexpected result? Because there are two locks. Now what is the solution of this? The first solution, which is we have already seen, to make use of only single object. Now this is not always possible. There could be scenarios where making use of single object is not possible. For example, we have a parameterized constructor inside this class bracket. So let me do one thing. In here, let us add a private entity, private string thread code. All right. And now let us add in a parameterized constructor. I will right click, navigate to source and generate a constructor using field. Alright, now as soon as we have this constructor, for example, for both of these threads, we would like to pass on some custom values for this thread code, and then we will display the thread code after executing and displaying the sequence. So in here, let me do one thing. We will type in generated by thread, and here we will display the thread code. Right, so in here we will give the name to the thread. So in here it would be named as thread 1 and we will give the name as thread 2. Now in this scenario, if for example we are making use of only single object, that's not possible, right? Now what is the solution of it? Let me execute the program and here is the output generated. All right, so there is a typo in here. It would be like generated by thread code. So generated by thread 1, generated by thread 1, and there is then some inconsistencies, right? Let me expand this a little. Now what is the solution of it so that we get a consistent result and we are able to make use of multiple objects? The answer is static synchronization. Now friends, what's an static element? A static element is an element which is independent and separated in memory. For example, we create an object of this bracket class and we have a static method. The static method would be independently placed in memory and it is not derived by object. That's a static element. If you would like to know more about static elements, you can visit the lecture on static keyword in our course. Alright, so that is one thing. So static element has independent space allocated in memory and they don't derived on object. Alright, so let's mark this generate method as static now. and as soon as we do this, there would be some warnings, there would be some errors. The first warning which we can see is in here, where we are trying to make the call to generate method by taking help of the object, and there is a warning because we are calling in the static method as a non-static way. Same would be the warning when we are trying to call the generate method with the bracket to object, which is cool. And inside this static method, we are also trying to access this thread code variable, but this variable is non-static and we are trying to access within a static entity, and there should be an issue. As a result, we need to mark this variable as a static, and in here when we are trying to do this, again there is some kind of issue, there is some kind of warnings. And now with warnings, if we execute the program, what would be the output? Let me show you. In here we are able to see that we are getting some weird output. Now friends, in here all of these patterns are not generated by thread 2, but somehow the weird output is showing that all of the patterns are generated by thread 2, which is not correct. So let us fix that. Now friends, whenever we make use of static elements, we need to handle the situation based on static elements. So in here we won't be taking help of objects, and whenever we mark a element which is a static element as synchronized, then the lock would be based on class directly. So take a note of it. So whenever we are marking a static element as synchronized, the lock would be based on the class directly. Take a note of it, right? So let me get rid of this constructor, we don't require it, and now everything seems to be okay inside this class. Then moving forward, in here inside this for loop, we will be firstly setting up the variable value. So in here we will type in the name of the class, which is bracket dot generate. Now as soon as we do this, we are simply calling in the generate method. But what about this thread code? The quickest and the best possible solution to this issue is get rid of this global variable. We don't require a property and we don't require a constructor either. We will receive the entity directly as a parameter to this generate method. In here type in string thread code. Alright, and that's it. And when we are calling in this generate method, we will pass in the string, for example thread 1, and let us do the same for the second thread as well, and we will give the name as thread 2. And now we have, for example, simplified this program quite a bit now, and now if I execute the program should work properly. Now as a result of static synchronization, all of the sequences are getting generated properly and we are getting a proper and a good output. If I execute this couple of times, you may understand how the synchronization is taking place, and you would be able to understand that in here thread 1 is getting executed first, then thread 2, then thread 2, then thread 2 again, then couple of times thread 1, and then couple of times thread 2. So multi-threading is working, the sequence is proper, there is no interference, and everything is working properly. Now moving forward, definitely you can have multiple non-static methods, multiple non-static elements inside this class as well, and you can work with them accordingly. Alright, so this was it for today's video. Hope you guys enjoyed it. Thanks for watching.